Okay, and so our last speaker before the break, the coffee break, is Jose Ignacio Orlando, Nacho. He's an associate researcher at CONICET. He's working with the Yatiris lab at the Pladema Institute in Tandil, Argentina. He also serves as the director of AI labs at Arionkoder through a CONICET STAN partnership. And additionally, he is a part-time professor at Facultad de Ciencias Exactas, UNICEN, where we studied together actually. And we met there as well, friends. And where he teaches fundamental of data sciences and workshop on applied mathematics. So Nacho, the floor is yours. Thank you very much.
Thank you very much, Enzo. Thanks, everything. Not necessary. All right, so today I'm going to wear my industry hat, so sorry for the academic people, maybe you will get bored. But I would like to start this presentation by asking, especially the younglings, how many of you are consider yourselves academic persons? Raise your hand. Okay, many hands. Nice. I would also leave your hands up. And how many of you, and raise the other hand, those who are below the 50% probability of looking for a job in the industry at some point? Okay, there are some hands there. I've been there at some point. I find the way to do that. I would like to tell you a little bit about what we do at Arionkoder AI Labs. AI Labs is basically a team of data scientists, machine learning engineers, and product designers, and we all work together to deliver value to users from different customers that we have, solving real-world challenges with machine learning. And we do this exploiting three things. Our scientific expertise, most of the people that belong to AI Labs are PhD level. A design mindset, we work closely with people from a product team designing applications that are covering the pain points from our users. And last but not least, we make use of smart engineering, which is an important part of developing tools for real-world impact, let's say. And for those who are interested in pursuing a career, I would like to say that there are lots of opportunities right now in what it comes to LLMs. And one of the things that I struggled with, I'm coming from the computer vision community, was trying to find the best way to learn all these things about large language models in a way that enables me to communicate with engineers that are working in the company. And one of the first stops that we need to make when it comes to finding that relationship or that sweet spot between one thing and the other was understanding a question that maybe the oldest in the room already have heard about in the old times of AI, but for the younglings is probably something new, which is the difference between automation and augmentation, which is an important thing to understand when it comes to user pain points and requests from our customers. So when we talk about automation, we are talking about using machine learning to replace a manual, tedious, and time-consuming task. Classic supervised learning, we have inputs, we have outputs, and we train a model to automate that process, right? In automation, we have a different mindset. We are talking about using the automation abilities in an augmentation way. So we try to help users to do the things that they do faster and more accurately using the abilities or the properties that are provided by them thanks to these automation tools, right? So most of the time, companies are looking for this. So it's a completely change of mindset. You need to start thinking about how you can use automation to augment tasks in an industrial setting. And when it comes to using LLMs, we know that the whole landscape of LLMs starts by training LLMs, doing fine-tuning on them, doing prompting, and there are many applications after that, right? So the first question comes, okay, I need to understand transformers in depth, I need to understand Q, key, V, the attention, the dot product, and all that in-depth information. And there is a good news for those of you who are coming from computer vision, for instance. You don't need to understand transformers that in-depth to already make real-world impact with LLMs, right? Why is that? Because in general, we don't train LLMs in an industrial setting. We cannot spend 6 months working with, I don't know, 2,000 GPUs training a model to make a difference. We barely make fine-tuning of LLMs. We just do that if we really need LLMs to speak a very particular language. And we can leverage lots of pre-trained models that are already available through open APIs, right? Not OpenAI, open APIs. Like Cohere models, for instance, Mistral models, and many providers that come with their own APIs for serving with large language models. So what I'd like to focus on this presentation, and I'm going to go super fast, is which are the different applications that you could incrementally learn about if you want to pursue a career in the industry. And I will bring you some of the examples of the things that we have done in Arionkoder AI Labs for serving some of our customers, so you can see different real-world scenarios where these could be applied. And the main frameworks that you need to learn about for this particular thing are not PyTorch, not TensorFlow. You need to learn a little bit about LangChain or Llama Index, which are frameworks that enable you to interact with different LLMs in a proper manner. So let's start by LLM prompting. I guess that most of you are experts already in prompting ChatGPT when you need to proofread a paper, if English is not your mother tongue, and things like that. And so LLM prompting is clear, I guess. The idea is to instruct an LLM to do something for us. What is the approach that we usually follow when it comes to prompting an LLM? The first step is always understanding the task that we want to automate. We need to clearly identify what are the processes that are followed to automate this task, because this is going to be part of the description of the task that we are going to provide to the LLM, okay? And one important factor on that is that all these tutorials that you could see online with prompt engineering techniques, take a look at them, because they provide really useful elements for you to do that. So for example, this idea of putting at the beginning of the prompt or before explaining the task, take your time to think about the solution. It's already demonstrated that if you take that into consideration, you will be able to achieve better results. Also, the idea of chain of thoughts, like focusing on instructing step by step how to perform a particular task, that's also helpful. So you should always try to leverage those tools that are already available online. In terms of recommendations, and well, here is an example. Sorry for the squares that you see. This had to be reducted because of the information that was there was sensitive. But here is an example of how, or one of those applications in which you can leverage LLMs. In this case, what we've been doing was taking very, very complex PDFs with contracts, tables, figures, and things like that, and we prompted GPT-4o using also its vision capabilities to extract different fields in JSON format that we could then feed inside a database, and then we could make queries out of that. So you could see that it was very simple for us, but we were able to process very, very difficult documents. Our recommendations when it comes to LLM prompting: first thing, use the vision capabilities if the content of the documents is very complex, for instance, if you're processing documents. But in other applications, you could also use prompt engineering to extract information from images as well. And last but not least, craft a data set for evaluation. We use LLMs in a zero-shot learning way sometimes, but this idea of building a training set now becomes building a test set, so we could calibrate the prompts and evaluate our performance there and repeat as many times as necessary so that we make sure that our implementation makes sense. Something more complex than pure LLM-based or LLM prompting are LLM-based workflows. This is related with RPA, robotic processing automation. We're talking here about automating different pieces of a process using multiple prompts or multiple calls to different LLMs. So the idea here is that we take a very complex process and we try to map it, for instance, using a flow diagram, something very easy to see. And then we try to identify in that pipeline which are those components that are suitable for automation using LLMs, right? So then the next step is just to write a prompt for every single one of those steps. So everything that I told you already about how to prompt an LLM applies here as well, but for each of those components that we are automating. One example here is an application that we have built for the eligibility process of health insurances in the US. You know that the health system in the US is pretty much complex than the one that we have here. And understanding how to pursue that process is very complex. So we mapped that process and we implemented all the necessary components so we can have a fully automated way of determining if a person is eligible or not for getting a reimbursement from a social security. 2 recommendations here. Pay special attention to the format of the inputs and the outputs, because you will gonna have many LLMs interacting one another. So in general, we use JSON format for that, and there are tools like Pydantic that enables you to instruct the LLM to use always the same format. And also craft a test set. You will hear me a lot talking about that. Then we have retrieval augmented generation. I guess that was the starting point for many of you who started to use LLMs and are not NLP native, let's say. Retrieval augmented generation is a task in which we provide context to the LLMs by doing semantic search on vector databases using embeddings that we extract from both from the query of the user, but also from different chunks of text that we extract from the databases. The idea here is very straightforward, and there is already a recipe for this. There are more complex ways of doing RAG, but in a nutshell, what we do is we take text, we chunk it in different pieces, we pass each of these pieces through an embeddings model, we generate a vector representation of each of these paragraphs, and we use that to build a vector database, and then given a new query, we try to match that embedding and see which are the closest ones. And then we use that as context in a prompt so that we input the user question, we have the system prompt, we have the user question, all these context, and then we get the answer, okay? So this is something that we have implemented. Lots of companies are trying to do that as well. It's basically a chatbot that is connected to our knowledge database. And basically we can ask questions like human resources questions. Can I take vacations? What kind of things do I have to accomplish to get this bonus or things like that? Well, this information is already in text form in a database. In this way, you can get a natural language answer automatically. This is really nice and really fun to play around with. There are very nice videos online to learn how to do this. Our recommendations here is review carefully the quality of the data that you're using as context. We have seen that sometimes we believe that the model is failing, and it's not the model failing, but the data that is already in the database that is not very good. And last but not least, evaluate all the components. Here you have the retriever, which is the component that takes elements from the database. You have the generative component that is the one that is producing the answer. So all these components are important and you need to validate them. There is an opportunity for automation of that validation using also prompt engineering, using a second LLM as an evaluator. So you can consider that as well. And it can give you at least a clue of how accurate the solution that you're implementing is. And last but not least, we have AI agents. We're going to call them LLM-based agents because we are machine learning practitioners, so we know that there is a difference between one thing and the other. So agents are special systems. Sometimes they are confused with the LLM-based workflows. But here we are talking about autonomous systems that perceive the environment, make decisions, and take actions to achieve a specific goal based on some degree of reasoning. Here, what we use is text as a proxy for reasoning. Okay. AI agents are intended for applications in which we need a lot of free will. Okay, so the first thing that we do in general when someone asks us to implement an AI agent is, do you really need that level of autonomy? So for example, if you're working with a chatbot that will need to use this tool or the other based on different requests from the users, then it's important to develop an AI agent. If that's not the case and you already know that there is a sequence of steps to follow, use an LLM-based workflow because it's much easier to implement first and it's much safer, let's say, in terms of the different misusages of this. So what is our approach to implement AI agents? We first start by asking ourselves these questions, and then we identify a proper agentic architecture. You will see that there are lots of posts online about different architectures to do so. Then you need to implement the tools for for this model and the perception components. And last but not least, you need to implement the system prompt. And here is an example of this chatbot. We incorporated into this solution the capabilities of querying a database. So, for instance, you could ask how many people is on vacation right now, and that requires running a query on a database. So we use a specific tool for that. And when we ask a question that we could answer with our knowledge base, we use the tool for retrieval augmented generation. That's all. That's all my presentation. If you want to know more about what we do, or if you want to know a little bit more about what we do in other verticals of AI, like computer vision, medical imaging, and so on and so forth, you can stop by our booth. You can also follow us on LinkedIn, Instagram, and X. And we are hiring, so if some of you are already curious about opportunities in the industry, there is a QR code in our booth, and I'm free to chat whenever you want. Thank you.
Thank you, Nacho, for the presentation. Okay, and now I think it's time for the coffee break, right? So we will be back at 4:15, right, Fefo? Yes, 4:15. Please be in time. We are going to have the last talk of the day, Sarah Hooker. So we need to finish in time because then we have the practicals, and otherwise all the program gets delayed. Thank you.